So we're going to go over solving equations, and then this tells you what you should have done by the end. These are called objectives. So we're going to do all these things. So what is an actual equation? So an equation is a number sentence that says an expression on either side of the sign equals the same number. So like 3 plus 1 equals 4. This is an equation. It has to have an equal sign. If it doesn't have one, then it's not an equation. And what we're going to do is we're going to have some where we don't know what the value is, or it says, hey, figure out if this is true or false. So in this one, for instance, if I go 4 plus 6, I can see that, hey, 10 does indeed equal 10, so I can say that it is true because I get the same number on both sides. And over here, 8 take away 3 is 4. Nope, it is not 4. It is 5. And 5 does not equal 4, so we say, nope, that's not true. It's false. Okay, here, we don't know what x is, which is why we use an x. And so we can't say whether or not it's true or false until we know what number somebody wanted to use for the x. So solution of an equation. When we're finding a solution, what we're doing is we're trying to find an answer. So lots of times we will solve one for x. Or sometimes they might give us one and say, hey, is this a solution? So we're going to try both of those things. So this one says, determine whether 8 is a solution of this. So the first thing we want to do is write out the equation. And then we're going to take this number and we're going to put it into x's place. So I'm going to write 8 plus 12 equals 21. Then I'm going to do this side. So 8 plus 12 is 20. 20 does not equal 21. So it is not a solution. Or we can say false. Notice that these are not the same, right? Which is why we say false. So what we're going to do is look for sometimes what's called an equivalent equation. So x plus 2 equals 5, x minus 1 equals 2, x plus 4 equals 7. These are examples of equivalent equations because all of theirs is they have a solution that is 3. So notice that if I put 3 plus 2, 5 equals 5. Yep. If I put 3 take away 1, 2 equals 2. Yep. If I put 3 plus 4, 7 equals 7. Yep. So these are why they're called equivalent. Equivalent is like, notice it has the word equal in it. This is just going to tell us how to solve. So we looked at this in review, so it shouldn't be something new. And we're going to try it here. So this says x plus 6 equals negative 9. Our idea is to get x all by itself. So we look at what's on the side with it, which is this adding 6, and we want to do the opposite of that. So we're going to subtract 6, and we're going to subtract 6. And then we want to rewrite it. And what you do to one side, you always have to do to the other side so it doesn't get jealous. And then I go negative 9 minus 6 is negative 15. And this is my answer. Now, what I'm going to do is I'm going to check my work. So I'm going to write out the original question, and I'm going to put negative 15, oops, I'm going to put negative 15 into its place. And when I check this, this does indeed give me, so it's true. Checks out. but again, this is my answer. Okay, this one we're gonna solve. It has a decimal just so that you can see the y is over here, so I'm gonna try and take this guy to the other side. So to get rid of him, he's being subtracted, so to do the opposite of that is to add 17.9, so I'm gonna add 17.9, and I'm gonna rewrite it. Maybe I'll make my decimals bigger. Okay, and then when I do that, I get 9.6. And if I check it, so I'm gonna write the equation, then I'm gonna put my answer that I found into its place. So I said it was 9.6, I'm gonna put it in here. And it checks out, it's true. Now we're going to do it with multiplication, and again we looked at this with review, so it shouldn't be new. So this one, the easiest thing to do is to actually, when you see a fraction over here, is to multiply by what we call the reciprocal. The reciprocal means the flip of it, right? So notice the 4 was here, now it's on the top. Notice this is 3. But again, what we do to one side, you always want to do to the other side. So we're going to do that over here also. This then cancels off this, and we're going to rewrite it. If you feel better to make this a fraction by putting it over top of 1, you can. Then remember that when we multiply fractions, we just go straight across. So we go 15 times 4 is 60. 3 times 1 is 3. Then you always want to make sure, can I reduce this number? And I can, right? So 60, I can actually divide by 3 evenly, so I get 20. So 20 is my answer. And then, of course, we're going to check it. So I'm going to put it back in. Now I'm going to go 3 times 20 over 4. So I'm just extending the line. You could make it into 2 fractions if you wanted to too. But I'm going to get 60 over 4 equals 15. So 15 does indeed equal 4. Remember that 3 times 20 is the 60. So it checks out. Now we're going to solve this one. So when I see that the x is being multiplied by 6, I have to do the opposite. So I'm going to divide by 6, divide by 6. Remember that what you do to one side, you have to do to the other. So now I'm going to rewrite it. And I'm going to check on my calculator. Can I indeed divide 96 by 6? And I can, and it gives me 16. And now what I'm going to do is I'm going to check it. So 6x equals 96, 6 times 16, so I'm putting it into the x's place. 96 equals 96, checks out. So when I do this on my calculator, I get that, and they equal each other, so we know that I did it right. Remember again that this is my answer. This is just me checking. Okay, now we're going to do it with a negative, so it's not any different. We're still going to divide by 7 because that's the opposite of multiplying, right? But we're going to divide by a negative 7 just to get rid of all of it. And what we do to one side, again, we're going to do to the other. Then I'm going to rewrite it. Then I'm going to try it on my calculator, and I'm going to see I get negative 12. And then I'm going to check and see, hey, is that right? That's a great thing about math. We can always check it. So I'm going to put it into here, put negative 12 equals 84. I get positive 84 equals 84 because a negative times a negative gives me positive. So it checks out. Okay, in this one, I'm going to do... well, I'll do one step up here. Erase that. So when there's this here and there's no x here, I'm trying to get this guy first all by himself. So the first thing I want to get rid of is this one. So I see it's being added, so what I'm going to do is subtract 9. And what I do to one side, I'm going to do to the other. Now I'm going to rewrite it. So this guy will cancel this one off. So now I'm just going to write 8x equals 33 minus 9. And then I'm going to collect what we call like terms. So these two are both numbers. So I'm just going to go on my calculator if I can't do it in my head and go 33 minus 9. And I'm going to see that that is 24. Then I still got to get the x all by itself, so I'm going to divide by 8, so x equals 3. Okay, and remember that we're going to check it, make sure, hey, is it right? So I'm going to go 9, 8x equals 33. And place my x with 3. BEDMAS says I do this first. And 9 plus 24 is 33 equals 33. Yep, it checks out. Okay, now this one looks scary, but before I go, the whole idea is to solve for x. Before I go doing that, I'm gonna collect like terms. So we're looking for things that are alike, and it's not a bad idea to like bring a highlighter and see, okay, this one has an x, oh, and this one has an exactly the same x. And over here, I see, hey, this is a number and this is a number. So I'm gonna collect these two together, which means I look at the coefficients in front, which is the numbers in front. So 4x minus 6x gives me negative 2x plus 7. So that's me collecting them. And then 10 and 12 would give me 22 plus 3x. So it's kind of like a way of simplifying. Okay, then you have to decide what way you're going to go. And by that I mean that I'm going to move the number to the other side. So I want to do this. I'm going to subtract 7, and what I do to one side, I'm going to do to the other. This gets rid of this one, and I'm going to rewrite it. Okay, and then I'm going to collect like terms again. So I'm going to get negative 2x equals, now notice I have to use my highlighter, this one and this one, right? So 22 minus 7 gives me 15 plus 3x. Then I'm going to move the x's to one side. So I'm going to move this guy over here. To do that, I have to do the opposite of what it's doing. So I'm going to subtract 3x, and what I do to one side, I always have to do to the other. This cancels off this. I'm going to rewrite this. Negative 2x minus 3x equals 15. Then I'm going to collect like terms. So I get minus 5x equals 15. And then I still got to get my x all by itself, so I'm going to divide by negative 5, divide by negative 5. So x equals, and I'm just going to do this part on my calculator, negative 3. Okay, and then to check it, I'm going to have to make my page smaller. So to check it, I'm going to go back to the original. So 4 times negative 3 plus 7 minus 6 times negative 3 equals 10. Plus 3 times negative 3 plus 12. So BEDMAS says we do these first, so that's negative 12 plus 7. I do this, that's positive 18. 10, we're going to do this, that's minus 9 plus 12. Okay, and then I'm going to collect the numbers on each side. So I'm just going to do this right across in my calculator. And and I get 13 equals 13. So it checks out. Oh, I think I left a page for myself to check it on this page. Just let me make sure. I did, but let's try this one instead. So let's do this guy. Okay, now what we're going to do is bed math. So we're going to go 8x minus 18. We didn't do anything to that side, but I see this guy. We have to do this. So I'm going to rewrite 6. 8 times x gives me plus 8x. 8 times negative 3 gives me minus 24. Then I see I have two numbers here, so I'm going to collect like terms. So 8x minus 18. Now 6 minus 24 gives me negative 18 plus 8x. Okay, now let's say I want to, let's move the x's this time just for fun. So I'm going to move the x's. So I'm going to go minus 8x minus 8x. Now look what happens when I do that. I was trying to move this guy to that side. This one cancels off that. So I'm going to rewrite over here. Now I have 8x minus 8x. Uh-oh. Notice that now I just have this, right? Negative 18 equals negative 18. When you have a number equals the same number and there is no x's, that means that there's actually an infinite number of solutions. Infinite means I can pick any number. So I could pick 1 and put it into x's place and it would be true. I could pick 3 and put it into x's place and it would be true. I could pick 5 and put it into x's place and it would be true. So you could get 105 and put it in and it will be true. So I'll just show you a couple just so that you can see what that means. You don't have to do this every time, but just so that you can see what I mean by that. We'll put 1 in. So I said x is 1. I'm just picking a number. So 8 minus 18 equals 6 plus 8. And do inside the brackets. That gives me negative 2. This gives me negative 10, right? 8 minus 18. 6 plus, plus I can put negative 16. Or you could say 6 minus 16. And I get negative 10 on both sides. Okay, what if I said x is 2 this time? Minus 18 equals 6 plus 8 minus 1. This gives me negative 2. This gives me negative 8. And look, I get the same thing. So that means like any number I pick to be x would make it true. Okay, now we're going to try this one. And we'll do BEDMAS first, so we'll get rid of the brackets first. So I'm going to rewrite that. Then I'm going to go 4 times x, so that would give me negative 4x. I'm going to go 4 times 6, that would give me negative 24. This one times that one gives me negative 4x. This one times that one gives me positive 4 minus 3. So BEDMAS, remember brackets, exponents, division, multiplication, addition, subtraction. Then I'm going to collect like terms. So I'm looking for, in this case, there's numbers. This one, there's also numbers. I'm going to go on each side. So 3 minus 24 gives me negative 21 minus 4x. No other x's on this side. Collecting these two, that's plus 1. Okay, now if I move the numbers, let's say, or let's move the x's again. So I'm going to add 4x, add 4x. Now, I was trying to move this guy over here. This one cancels off that one. I'm going to rewrite it. Negative 21 equals negative 4x plus 1 plus 4x. But I notice when I do this, I get another uh-oh. But this time, notice that I get negative 21 on this side and 1 on this side. These do not equal each other, right? When we get there not equal to each other, there is actually no solution. So there's actually no number that we can put into x's place up here that will make this actually true. So there's no solution. This is just an overall guide if you're having problems figuring out what to do, and it's not a bad idea to like print this off or have it beside you so that you remember which way to do it. Okay, now you should be able to do your homework.